I'm holding in my hands 11 kilograms of aluminum. Why? Because today we're talking about classifying matter, and of all the millions and millions of kinds of matter out there, I thought it'd be fun to start with this one because it's just cool to hold 11 kilograms of aluminum. Chemistry is the study of matter, which includes anything that has mass and takes up space. Now I know this has mass because I'm feeling all 11 kilograms of it, and I can see it has a volume, so it must be some form of matter. But how do we go about classifying what form of matter something is? It might be helpful to imagine what the particles of a substance look like. So in chemistry class, we often use balls or little drawings of balls to represent atoms or molecules. Take a look at these two models, which represent the first big difference between types of matter. This first one only contains one type of bead, and that represents the types of matter that only have one type of particle in them. We call these pure substances. There are two kinds of pure substances. The first is when all the particles that are in the substance are simply atoms. They're just single atoms by themselves. Examples would include my giant piece of aluminum. This is a chemical element because all the atoms in here, to the best of my knowledge, are atoms of aluminum with 13 protons each. They're all similar to each other. The periodic table is our master list of the different types of atoms in the universe. And if you ever had a sample where all the particles were the same type of atom, that would be a chemical element. On the other hand, if all of these particles happen to be molecules or groups of atoms joined together, we would have a chemical compound. Some examples might include water, in which all the particles are water molecules, polystyrene or styrofoam, or one of my favorites, propane. Molecules can get pretty complex, even way more than this one, and we often use models like this to represent them. But at any rate, if you had a sample and all the particles of that sample were the same type of molecule, you would have a chemical compound. Now let's talk about mixtures. Mixtures are samples of matter that contain more than one type of particle, and there are lots and lots of mixtures. Most of the things you run into every day are mixtures. But there's a big difference that I want you to note between this one and this one. And it's not about the color of the balls. We could have used any color of the little beads. Now the big difference here is that this one contains a couple of types of matter, and they're evenly distributed throughout the whole sample. Whereas this one has little blotchy areas, like represented by, we got these red ones here, and then some yellow ones over here, and the white ones all around. So this one is uniformly distributed. This one is not uniformly distributed, and that represents the two different types of mixtures. We use the fancy term homogeneous mixture in order to describe this one. Homo means the same, homogeneous means all in the same phase. They're all uniformly distributed throughout the sample. One example might be my morning coffee, which contains all kinds of flavor molecules all dissolved in water, and they're evenly distributed throughout. Or this mixture of copper sulfate and water, in which the copper and the sulfate are evenly mixed throughout. It's not like one part of the sample is more blue than another part of the sample. Now the two I've just shown you are also special types of homogeneous mixtures called solutions. And a solution is what results when you take a solute, the thing that gets dissolved, and you put it into a solvent, in most cases water, but it could be something else, and you allow them to get dissolved together. The solvent dissolves the solute, and we get a solution, which is a homogeneous mixture. Another special type of homogeneous mixture is called an alloy. And an alloy is just a mixture of two or more elements from the periodic table. Usually they're metals, but sometimes they're not. In the case of something like carbon steel, like this, you would get iron atoms, but also mixed in would be some carbon atoms, and the resulting alloy has a lot more strength than regular iron does. So if you ever had a sample in which you'd have two different types of metal all mixed together, you would have an alloy. The other type of mixture is one in which the particles are unevenly distributed or in different phases, and we call those heterogeneous mixtures. Hetero meaning different. One of my favorite examples of a heterogeneous mixture is this chunk of granite that I have. And it's clear as you look at it that there's definitely pink areas and there's black areas and there's white areas. There's different areas or different phases going on here, and that indicates that this is heterogeneous. But sometimes it's hard to tell if something is homogeneous or heterogeneous, depending on the size of the little phases or the grains. Take a look at this rock. This looks pretty uniform, and it's kind of the same color throughout, so you might go ahead and say it's homogeneous, and maybe from here it looks homogeneous. But maybe if you blew it up and looked at it, you might find little white grains and little red grains and different things that you could tell apart from each other. So sometimes more information is necessary, but we do the best we can with the observations that we can make. Other examples of heterogeneous mixtures might include sand. You can definitely see the different grains in there. Or this really weird drink with all these like floaty things in there. So there you have it, the four main types of matter. The first two have particles that are all the same, and those include elements, where all the particles are atoms, and compounds, where all the particles are molecules. The other two are mixtures in which there's more than one type of particle present, and we call those homogeneous and heterogeneous mixtures, depending on whether they're evenly distributed or unevenly distributed. So armed with this knowledge and your simple powers of observation, you can now go through your day and classify all the different types of matter that you see.